everybody and welcome to my channel. Today in this video, we are going to learn how to perform an independent samples t-test for unequal variance. So when we want to compare two populations to see if there are significant difference between the mean of the population or not, we first of all need to determine whether they are independent or dependent samples. So in this video, here we are going to take a look at independent samples, also known as unpaired sample t-test, and we also need to know whether the variance of two samples are equal or not. So this video shows you how to do a t-test for equal variance. As always, we have a null hypothesis here, as you can see, and alternative hypothesis for a t-test. And in this case here, my null hypothesis is that the population mean are equal or there is no difference in the mean of a population or a group. And alternative hypothesis is that the population are not equal or there is a difference in the mean of a population or a group. And we are going to test that an alpha value of 0.05. I'm also going to use this alpha value for other tests in this video. So before we start, let's read some data and load the libraries. Here I have library tidyverse, ggplot2, dplyr, and read excel. So as you see, I already run these libraries, and now I'm going to read the data file. You will find the link to this information in the section of this YouTube page. So I'm going to read this data file and store it in a vector called body temperature. As we write here the body temperature as a vector, and we are reading a read excel file, and this is the path of my file, and in the end it's t_test online classroom.xls is the file name of my data file. So I will run this code of chunk here, and as you see, our code is completely read, and we have a body temperature data vector here. And now we can see our body temperature data, how the body temperature data is here. Now let's take a look of the body temperature data, and we run this code, and we can see a table of 64/2. So here we are comparing the body temperature difference between the man and the woman, and we have almost 64 reads. And if we scroll the data down, here we have two NA values also in the woman's data. So we have to keep in mind a little bit about the NA values. So now we are looking here, what is the difference between the man and the woman body temperature? Is there an effect on the temperature? So I'm comparing the mean of a body temperature for man versus woman. So as always, with these tests, I want to determine, first of all, if t-test is an appropriate one for these two data sets. So I need to check the normality. So I'm going to do that using the Shapiro test for both man and the woman body temperature. So let's run this line of code, and we make first the two groups of a different. First we make a two groups of man and woman body temperature, and now we can see here we got an two vectors. One is in a man's underscore temperature and another is a woman's underscore temperature, and we can run this code to check our data. So we can see that data is nicely distributed in two groups, and we have all the values here. So now, after having the two separate groups for the man and woman, I'm going to check the normality for both the groups. To check the normality, I'm going to do using a Shapiro test for both man's temperature and the woman's temperature. So here we have a Shapiro test to check the normality of the normal distribution for both the groups. So we write here Shapiro.test, and in the bracket we give the vector for the man's temperature, and again we write a Shapiro.test and we gives the woman's body temperature vector, and we simply run this code here, and this code will give us output in the form of Shapiro-Wilks normality test. And here we can see the p-value for the man's body temperature is 0.3 and woman's body temperature is 0.07, which is slightly higher than our alpha value of 0.05. Therefore, the man's body temperature and women's body temperature are distributed normally. In both cases, p-value are greater than alpha values that indicate that both the sets of the data are normally distributed. Therefore, the t-test is an appropriate test to use for both the data sets. If they were not normally distributed, then the other tests such as Mann-Whitney test would be more appropriate. And now the last thing I need to do before I run the t-test to check for the variance. So I need to know whether the variance are equal or not, because the type of t-test I conduct, the formula that are used and the calculations are done will vary depending on whether the data have equal variance or not. So I'm going to use the variance.test function, and there is a simple comparing the two sets of the body temperature. So I'm going to compare the man's body temperature versus the woman's body temperature. So here we have the variance test. We write just simply variance.test and give both the vectors of a man temperature and a woman body temperature. And this function going to calculate and determine the variance for both the groups and compare them using the variance test function. So we just simply comes here and run this code, and this code gonna give us an output, and output here is in the form of a f test. And as we can see, the f is statistics of 1.16, but the most importantly, we have a p-value here which is higher than or greater than our alpha value of 0.05, and therefore our variance are equal. So the null hypothesis in this case would be that the variance are equal, and with the p-value we fail to reject the null hypothesis. So now we know our data are normal and the variance are equal, and that gives us enough information to run the t-test. Now the function to run the t-test is called t-test. So in this t-test we need to tell few things, and we just come here and write a t-test that I already write it here, t.test, and we give both the vectors here like a man's body temperature and the woman's body temperature. And from our normality or Shapiro test, we get to know that the alternative, our data is two-sided. So we gives here alternative as a two-sided, and our variance test also showed us that the data is not paired. So we write here paired equals to a false because we have unpaired samples, and the variance of equals to 2, as we check from the variance test our p-value is higher than the alpha value. So we give this all the parameters in the t-test, and we just simply run this code of chunk, and it gives us a really nice information about the two sample t-test. And we can see here we got quite a bit of output appearing now, and here we highlighted the t-value or t-statistics as a minus 2.095. An important thing for reporting the results of our t-test to report the degree of freedom is 124. And really important to here is our p-value, which is at 0.04, that is slightly less than our alpha value of 0.05. So that we previously said, but this is a binary black and white decision. So if my p-value is less than the alpha value, I reject the null hypothesis. So to go back to my hypothesis at the top here, I have a sufficient evidence here to reject that statement that the population mean are equal in favor of alternative hypothesis, that the population mean are not equal. So in other words, I have found here that there is a significant difference at the significant level of 95% from the taken from the alpha value 0.05. I have found that there is a significant difference between the body temperature of man and woman in the samples that I have used here. We also got some confidence intervals. So we have 95 confidence interval here, and these two values telling us that we would be 95% confident that the t-statistics for the population would be lies between these two values. And we also getting the mean reported there as well. So quite a lot of information in the output that you can be very that can be very useful for writing the report of the t-test. So that's how you conduct a t-test for independent samples or unpaired data in R. I hope you found this video useful. Thanks for your attention.